continue from where we stopped. All right. Now, by now, I'm sure you already have an understanding of what Git is. Okay. So in this video, we want to get into the hands-on. I want to start practicing, all right, our Git skills. Okay. Now, expect that if you have, watched the set of videos, the set of video that we posted, you should have your Git repository created already, and you should be able to log in just like what I have on my screen at the moment. Okay. So you should have the same thing that I have here. Now, you may not have any repository, okay, on your own, GitHub platform as of now, but that's absolutely fine. Okay, so let's head over to our Linux machine here, okay, to see how we can start practicing our Git skill. Okay, now here, I don't have any folder here, right? And one thing that you must know is before you can start using Git, you must have installed it on your system already. Okay, so if you're using Windows, I would really encourage that you go through the tools video that we posted on the YouTube channel. All right, so that will give you an idea of how to install Git and any other tool that we're going to be using in the course of this class. All right. Now, I am assuming that you've already installed Git on your system. So whether you're using a Windows machine or you're using Linux or Mac, it doesn't matter. What matters is you have the tool installed already on your system. Now, if you're having issues with your Windows machine as well, you can actually just go over here, to your AWS, just go to the EC2 section, or just spin up an instance, right? Just like we did for the Linux class, all right? So just spin up an instance and then you can follow whatever it is that we're doing in this session. Is that okay? Now, so basically what we want to look at is how to use this tool, all right? And that is basically our focus, all right, today. Okay, so we want to see how we can use it. Now, if you want to use Git, the first thing, of course, is that you have it installed already. So that's the first thing. Now, the next thing is let's create a folder, right? So mkdir, all right? If you've not gone through the Linux class, I encourage you to just go through those videos, all right, so that you can basically understand what we're doing. Because, I mean, at this point, we're going to be doing some Linux commands. So, and I expect us to have gone through, all right, those Linux videos so that you can follow whatever it is that we're doing, all right? So let's make a directory and let's call it test git. Okay. Now in this directory, I have it here, test git. So I'm going to do cd test git. Now I am actually in this directory. Okay. Now if I do ls-a, I really don't have anything here in this particular directory. So this is a directory like any other folder on my system. So the question is, how do I turn this directory into a Git repository? Remember, we talked about the working directory in the last video, right? So this test Git is more like a working directory, but it is not a Git repository yet. I hope you're on the same page. So it is a working directory, but it is not what? A Git repository just yet. So there are commands that you have to execute in your working directory that will make the working directory what? A Git repository. So you need to be able to understand the difference. So the fact that I have a folder here and the fact that I have Git installed does not automatically mean that this directory is what? Is a Git repository. So there are two different things. A directory is a directory. A directory is a folder. A Git repository is basically a directory that has been transformed into a Git repository. So the question is, how do we transform this directory into a Git repository, right? Now the command to do that is git init, right? So git init basically means git initialization. So you want to initialize this directory, all right, to become a Git repository. So that is what git init basically means. So git initialization. So initialize this directory, all right, to become a Git repository. Okay, so you press enter. Now, when you press enter, now you don't have to bother about what you see here, all right? You can just ignore all of that, okay? Now, but what is important is that it says initialize empty Git repository in home ubuntu testgit.git. which means it created a .git directory inside of this working directory. Okay, but if I do ls, I won't see it because anything that starts with a dot in Linux is it's treated as what? As an hidden folder or hidden file. But if I do ls-here, I will see that I have my .git, all right, inside of this folder. Now, if I do git status, okay, basically just to check the status, all right, of my git repository. Now, don't forget, my test git directory is now what? Is now a git repository. So git status, all right, is going to work. So it's one of those commands that you can use to check if there's anything you need to add, if there's anything you need to commit, if there are files you have not staged, all of those kind of things. You can use git status just to check, what is going on within my git repository. Now, one thing you must understand is that all of this git command will not work if you have not initialized this directory as a git repository. Okay, now for example, take a look at this. Let's look at this. So here, my folder is already initialized as a git repository, but I can actually just undo that. So how do I undo that? I can just say rm-rf.git. Okay, now it's saying what? Cannot remove .git, all right, because it's what? It is a directory, right? So now something was missing here actually. I didn't remember to put the -r, which is recursive, okay? And then I press enter. Now if I do ls-a, all right, it is not, all right, I don't have the .git directory again here. Now if I do git status, what do you think will happen? What do you say? It says not a git repository, which means it is the presence of that .git that was created by git init that actually makes this directory what? A git repository. And that is what makes it possible for us to execute the git commands. Do you understand it now? So if I didn't initialize the directory as a git repo, then I can't execute git commands against or within that directory. I mean, there's no git command that I want to run. If I do git add, it's going to tell me that it is not a git repository. Okay? Because the directory has not been initialized as a git repository. It is just a directory. But now, if I do git init, okay, and then I do git status, the command works. Because now it is seeing it not as a directory, but what? As a git repository. Do you understand that now? So if you don't initialize a directory, there's no way you can run git commands against that directory. So you have to initialize the directory, and then you can now run the git commands against the directory. Because now Git is not seeing this as a directory, it's seeing it as what? A repository. Okay, so let's clear the script. Now this has been initialized as a directory. Okay, so I mean, we need to start, creating files, start tracking changes, and doing a lot of things and all of that, right? So I can say touch. Okay, so let's say like 5 files, right? So I'm going to use this command touch.5. All right, close that and then txt. Okay, now we did all of this in the Linux class. If you've not watched it, just go and watch the Linux video. Okay, so you understand what this means. All right, so I'm going to press enter. Now, if I do ls rather, right, I can see that I have my file 1, 2, 3, 4, 5. Right now, if I do git status, okay, now look at the information here. File 1, 2, 3, 4, and 5. Okay, now Git is seeing these files, but it calls them as what? Untracked files. Untracked what? Untracked files. So these files, right, I can see them in my repository, but I mean, I'm not tracking their changes. I don't know anything about them. Now, that was the analogy that I gave in the last video, that when you take your child to a school, right, to go and inquire, oh, well, your child loves the school, you like the school, you want your child to come to the school, but of course you go there to inquire. Now, the fact that you are within the premises of the school does not automatically mean that your child is what? Is a student, all right, in that school. Okay, so here, the fact that we have files in this repository does not mean that they are tracked already by Git. Do you understand that analogy now? Now, If you take your child to the school, what do? You fill a form, you submit the form, and sometimes you will do an exam, all right, your child will do an exam, and then they give the child admission, and then the child resumes as a student. Now, when the child resumes as a student in the school, now the school take responsibility for the well-being of the child while the child is within the premises of the school. All right. So the same thing also applies here. Now, when you run a command, which is git add, you are basically filling the same form. You are basically doing the same thing that you did when you take your child to the school. So basically, you are saying, Git, I am handing over these files to you, so help me to manage them. Now, Git will start tracking those files. So as you edit the files, Git will start tracking the changes, the things you added, the things you deleted. Git will start tracking. If you rename the file, Git will track it. But at this level, we have not handed it over to what? To Git yet. So Git is not going to try. So and that's why it says here, all right, it says here what? Untracked files. All right. So how do we hand over these files to Git for Git to start tracking? We use the command git add. Okay. Now, the git add command, all right, you can basically specify the name of the file. So you can say file1.txt. You can say file2. All right, txt, like that. But I mean, if you have hundreds of files, you can't be adding the name one by one, right? So what do? So you can come here basically and just say git add dot. So git add dot basically means every file that is in this working directory, all right, should be added to the git commit, to the git staging area. Okay, so here I'm going to press enter. Now, if I do git status now look at it now. It says what? Changes to be committed. So Git is responsible for the files now. Git is aware, all right, that, oh, I have new files that have been added to me, right? Oh, I have new files that have been registered for me to manage, right? So it is now the responsibility of Git now to begin to track the files. It is now the responsibility of Git to begin to monitor the changes that we make to the file. So at this point, Git does not have any excuse again. So it is responsible, all right, for this file. So the same way, when your child registers in that school, the school cannot make excuses if anything happens to your child in the school, because they are responsible for the well-being of that child while the child is on the school premises. So here, for these files that we have here now, we have handed all of them over to Git. So Git is responsible, all right, for managing these files. Okay, so now we've added it. Now, another thing that you must also know is that there are different stages like we saw in that slide. So there's the staging area, there's the commit, all right, area as well. Now, at this point, we have staged these files. So the next thing after staging is to save the files to our local repository, right? Now, saving the file to a local repository does not mean you are going to run some kind of save command. Just basically is a simple command. And that command is what? Is git commit, all right, -m, and then that's the pattern. Now, what does this mean? So git commit is more like, you maybe, for example, you're doing something on Microsoft Word, and then you're done with what you're doing, you want to save. The moment you save that file, you're basically committing that file into your hard drive. So tomorrow, when you turn on your laptop, all you need to do is to go to the location where you saved the file, and then you can open it up again and start working on it, right? So the git commit command is the same thing, right? So basically, all of the changes that we have made, we're saving them into the repository permanently now. Because so far, all of the things that we have done has not been saved. Okay? So that is why you have two levels. So there's adding, which is Git. I've made some changes. I'm handing it over to you, manage them for me. And then you have another stage called the commit phase, which is, all right, everything has been done. I'm okay with the changes that I've made. Now I want to save permanently. And that is where the commit phase comes into the picture. All right. The same way you can be working in your Microsoft Word and then you're not saving your changes until you're done with the old file, and then you now save finally, you close your laptop, and then you're done for the day. All right. And that is exactly what you have here, all right, as well. So by the time you do the git commit -m, right, you're basically saying, I am now saving all the changes permanently. I don't have anything that I want to add. I don't have any changes I want to make at this point. I want to save my changes. And that is where git commit comes in. Now, but if you look at it here, there's a little something here, right, which is -m. So what does that mean? Now, in Git, when you are saving permanently, all right, the idea is that you must pass a message. Now, the purpose of the message is for your team members to understand the thing that you have done. All right? So the message alone can give them an idea of the changes that you have made. Okay? So for every commit that you do in Git, you have to pass in a message. That message, all right, gives, all right, your team an idea of the changes that you've made. Now, it doesn't mean they can decode, but it just tells them that, oh, okay, this person has done this. Oh, okay, we can see what he has done, right? So that's where you have to pass in a message. And you do -m. Passing your message between, all right, two, okay, apostrophe there. Okay. So here you can say added, let's just say added 5 files. Okay, that can be your message. Okay, now this is going to appear on your GitHub platform. So if you're using GitHub, you're going to see. If you're using GitHub, you're going to see the message. Okay, now if you press enter, now look at what you have here. All right, so now of course it's giving us some errors here, right? But look at what you have here. It says master root commit, and then it generates this ID. Now, and then this is the message that you've added. Okay, now for every commit that you make, all right, it generates what you call a commit ID. Now, that commit ID is what is used to track the changes that you've made. Okay, so here is what a commit ID. All right. So we're going to delve into, because I mean, sometimes you make some changes, you've made some commits, and you want to reset certain things, right? You want to reset something, or maybe you just forgot, I need to correct something and I've committed. Maybe you've not pushed to your repository, right? You've not pushed to your remote repository. It is still local. You can actually revert some changes. That's possible. We're going to get into all of that. Now let's take a look at this error that we have here. Now, after we did our git commit, right, it says master and then root commit, and then it generated an ID for us. And then here we can see, all right, the message. Okay. Now, when you make a commit, there are a few things that happens. Number one, it generates a commit ID that will be associated to that, all right, that operation. Now, commit here is basically you saving something permanently. And for doing that, there's an ID that will be attached to that operation. That ID can be used to track the changes, can be used to see that, oh, okay, at so time, this person made this change. This is the ID that connects to that change. All right. It's just like anytime you deposit money into your account, a transaction ID is generated every time. And that transaction ID is basically unique and it is for that transaction. Okay. So if somebody sends money to your account as well, there's a transaction ID. And that transaction ID is used to identify that particular transaction. So in this case, the commit ID is also a unique ID that identifies that particular operation at that point in time. So if you make any change now and you do another commit, another ID will be generated to identify that specific operation. Is that okay? So that is what the commit ID is about. Now, let's take a look at some of these things that is saying here. So it says your name and email address were configured automatically based on your username and host name. And it says, please check that they are accurate. You can suppress this message by setting them explicitly. Okay. So now, how do you set this? Now, normally, when you're working with Git, you have to set what you call your username and your email. Okay. Because apart from the commit ID, okay, another thing that also gets appended with every commit that you do is that username and your email. like I told us in the last video, every commit you make, right? What version control basically is that you can see the person who made the change. Okay, so when you commit anything and you push it to the repository, the system is able to give you the name and the email address of the person who made the change. And so that is what Git here is complaining about, that we need to fix the identity used. Right? The identity has to be what? Has to be fixed. So how do you do it? Now let me just show you one way to do it, and then later on we'll move into other ways by which these things can be done, right? So here you can say git config --- global, and then you say user.name, all right, and then you put your GitHub username, okay, your GitHub username or your GitLab username, okay. So here I'm going to put my own. So I have this DevOps card here. All right. So you make sure you close that, right? And then here you have to pass in your email as well. All right. So let me see how that can be done. So here I'm going to call that up again, and I'm going to call this email. Sorry, email. All right. So I'm going to call this DevOps card, all right, at gmail.com, right? And then you close that as well. And you press enter, right? Now, once you have done that, you have basically set your identity. Okay? The identity has been set. Now, let's take a look at something again. So here, I can come here and say nano. Let's just use nano file txt. Okay? So we can say welcome. All right? So let's save that. Let's exit. So if I do git status, right? So it tells me that this file has been what? Modified. Now, because we have added this file before using the git add command, so git here is saying that what this file has been what? Modified. So which means git was able to detect that we have made some change to this file. So that tells you that git actually does what? Actually reads your file. And that is how Git is able to know what you have done, the changes you have made, and all of that. So Git actually does what? Actually reads your file. Is that okay? So here I'm going to say git add dot, okay, or I can either say, since it's just file one, I can say file1.txt, then I press enter. And then if I do the git commit again, okay, so git commit -m, I can say pass the message file1.txt modified. And then I press enter. Now look at that. One file changed and one insertion. Now, which means Git read the file and discovered that, oh, we've added a line to that file. Which means if I delete something also, Git will also catch it and say, oh, something was deleted. Is that okay? Now, the question is, before we delve into other aspect of Git, like how do I revert my changes, how do I do all of this? Now, I quickly want to show us how you can actually configure, how you can connect your GitHub, all right, with your local repository, so that as you're making your changes, you can also push, all right, to the remote repo. And I believe that is important. Now, here on this GitHub platform, okay, on this GitHub platform, we don't have a repository created. So I'm going to click on new. All right. So click on new. And then here, I'm going to say test git. Okay. So that's the name I just want to use. Just a simple name. For now, we're going to stay with public. Okay. And then let's say create. All right. Now this repository has been created. Now there are two ways to authenticate with your GitHub platform. You can authenticate with HTTPS, or you can authenticate with SSH. Now, SSH is the recommended way of authenticating with your GitHub platform, right? The HTTP method has actually been deprecated. I mean, especially when you're using Ubuntu, Mac, and all of that, you may not be able to use the HTTPS method because, I mean, you're authenticating over the internet. But in order to allow for secure communication, SSH is what is now being used. So that means we need to have all right, an SSH key that we're going to use to interact with our GitHub platform. So that means we need to generate an SSH key that we need to use. So how do we go about generating an SSH key? So here, I'm going to click here, all right? And then here, I'm going to come to settings. So let's open up these settings in a new tab. And here, I'm going to come here to where I have SSH and GPG keys. So click on that. Now you can see that I don't have any keys in this account, right? So let's take a look at this together. Now here, I'm going to go through this documentation so that we can see how you can generate your keys. So click on that, open that in a new tab, and then come here to generating a new, or I just click on this guy, generating a new SSH key and adding it to the SSH agent. So click on that. Now I'm going to be going with Linux. Of course, it's the same thing actually for Windows and Mac, right? So, but let's just stick with Linux. But like I said, it's the same thing for Windows, it's the same thing for Mac. So the first thing we want to do is we want to generate a new SSH key so that we can authenticate with our GitHub. And so whatever it is that we do locally, we can push that, all right, to our remote repository. Okay. Now, here, let's see what we can do. So here, you can generate an SSH key. Now, there are two algorithms. There's the ED25519, and you have the RSA-B, all right, you have the RSA basically. Now, the RSA is more like the legacy, algorithm. It's been around for a very long time, all right. The ED25519, it's more like, the newer version. So you can use the two, actually. Okay, so but let's just go with the ED255. Okay, you can use the RSA as well. So let's go with that and let's put that here. So we're going to be generating the SSH key on our system. So we're going to be doing that on our system here. That's how you generate it. This one here, make sure you correct email address. All right, so put your correct email address. All right, and then you press enter. Now it is going to generate a public and private key pair, okay, just like your normal AWS key pair. So here, enter file in which to save the key. Right now, this is the default location, and I would really encourage that you leave it as this default. All right, don't try to change this location. Okay, just leave it as the default, and then you just press enter. Now, passphrase, just press enter, enter, and that's all. Okay. Apart from the first line that generated the key for us, everything should just be enter, enter, and enter. Now you have generated the key. So how do you now connect, all right, that key to your GitHub account? Okay, so how do you do that? Now on the GitHub space, you have a place where it says new key. So click on that. Now on your server, you need to navigate to this particular location, all right, and then get the content of this .pub. All right, so the .pub is the public key. So this public key, we're going to copy that into our GitHub platform. All right, so we copy this and then we put that in the GitHub platform. Okay, so by the time we want to authenticate with our GitHub repository, we're going to be using a private key that we already have here, which is this one. So this is your private key, all right, and this is your public key. So the one that ends with .pub is the public key. All right, so this one is the private key. So the private key is what we're going to use to authenticate, all right, against your public key. So here, I'm going to grab this, all right, right click, and then I'm going to say cut, all right, put it there, and then you press enter. Now, this is the key that you have. So you're going to copy this. So make sure you copy it without any white spaces, okay? So copy that, come back here, and then you can paste it here, and you can give it a title if you want. So you can call it test key. Okay, so you can call it test key, and then you say add SSH key. Okay, now once the key has been added, there's one more thing that we still need to do. So if you look at the instruction here, it says that we have to add the SSH key to the SSH agent. Okay, so here you will copy this line. All right, copy that line and then drop it here. So the SSH agent has been started up. All right, and then you can copy this line as well. So this one is basically pointing to your key. Okay, so what I have here, now this line here, same thing as this. Okay, is basically what? The same thing as this. Because your home/Ubuntu is the same thing as this tilde sign. Remember, in the Linux class, we said the home directory is identified by what? By the tilde sign. Okay? So this here is the same thing as referencing this path. Okay? So now you can see that we are adding our private key to the SSH agent, not the public key. All right? So the private key, is what we are adding and not the public key. So take note of that. So you press enter. So here it says identity added. All right. So which means your private key has been added to the SSH agent. So which means your private key is now is available, right? So it can be used, it can be called, it can be used now because it's been added to the running agent. Is that okay? Now, that's what you need to do. So now you can go back to your repository. So we've created this repository and then we need to connect, all right, with our, all right, SSH. Okay. So here I'm going to be using the SSH to connect. And the way I will do that is by running this command that says git remote add origin. Okay. So I'm adding what? Origin. So which means I am telling my local repository that, everything that I am committing locally, if at any point in time I want to push, okay, this is the URL that you should use and push, all right, to this URL. That is basically what the origin actually means there. Okay, so the origin means anytime I run git push command, I am telling my git tool, which I have locally, that this is the remote origin I want you to push to. Okay, so you copy that and then you paste that here and then you press enter. Now, when you press enter, let me clear my screen, right? That is actually being added into your git config file. Okay, now remember that here we have the .git. Okay, the Git folder. Now, inside this .git folder, you have a config file that basically stores, some information. So if I go here and I say, or I can say, or let's just say now, all right, .git/config, and then you press enter. Now you can see that that remote origin that I added, right, the URL has been added inside of this config file. Okay, it's been added already. Okay, so that is basically what the config file is. So every of your configuration that relates to Git is actually kept in that folder. Now, how do we push? Okay, so let's do Git status. Okay, so we've committed every changes. There's nothing again to commit, right? So I can come to here and say git log, so I can see the log and see all that I have done so far, right? So here I can see that this first commit was committed by the author Ubuntu, which means he used my system username. Now that was when I have now configured my username and my email. But you can see that the second commit that we did, it actually specified the author and then the username and then the email of the person who made the change, right? And then here you are seeing the the commit ID associated with this specific operation, all right? So that is basically that. So now, if I want to push, I'll say git push. Now I am pushing to this repository, this remote repository in particular. I am pushing there for the very first time, right? So here I'm going to say -u origin, okay, origin, and then I have to specify the name of the branch that I want to push to. Now, in the next video, we're going to be talking about the concept of branches. All right, we need to understand what it is. Okay, but you know what? If I just come here and I just say git push, for example, if I just say git push, now it's going to give me, all right, an error, basically saying the current branch master has no upstream branch. All right, so I need to set my upstream branch for the first time because this is the first time that I'm pushing to this repository. And so setting up your upstream branch is important, right? And it is always advised that whatever branch that you use locally should also be the same branch that you're pushing to in your remote origin, so that you don't make mistake at any point in time. Okay, so here I can just copy all of these. All right, copy that and paste that, and then I press enter. And now it is trying to authenticate, all right, with my SSH key, right? So I will say yes. And then if everything is fine, all right, my my changes have actually been pushed to my repo. So if I come here and I refresh, right? So here I can see all the files. So file 1, 2, 3, 4, 5, and then I can see the message. Look at that. File 1 txt modified. I can see all of the messages. And importantly also, I can see, all right, the ID. Okay, and I can see the name of the person who committed it. So it says DevOps account committed 12 minutes ago. All right, and I can see that so far, 2 commits have been made. And of course, if you look locally, that corresponds, all right, here. So if you look at your Git log, for example, right, there are 2 commits that have been made. Okay, so if you look at it here, so you can see that it is correct. So if you click on this commit, all right, so it basically shows you what was done. So you can see that this one was by the Ubuntu, which is the system user. And then this one was by DevOps card. And then this is the message that they passed in when they were committing it. So if I click on this one, all right, I can see what the person has added. So here I can see there is a plus sign, so which means the person added welcome to this file. Okay, so and if somebody deleted something too, you can also see it from here, what they deleted, what line they deleted from, what they added, all of those kind of things. All right, so in the next video, we're going to delve more, all right, into some operations, into some commands, all right, and then basically how we can configure, all right, our username and email to be, to basically be permanent, so that at any point in time where maybe you stopped working, for example, and then you want to go back to your repo to do some stuff, all right, you don't have to configure your username and your email every time. And we're also going to see how we can also configure our SSH key such that we don't have to add it. All right, we don't have to run the SSH agent every time. How can we manage all of that? So we're going to see all of that in the next, all right, video. So thank you so much, guys, all right, for joining me today. All right, so in the next video, we delve into other aspects of Git, all right, as we move on in the course of this class. So thank you so much. I will see you, all right, in the next video.